Hey students, welcome back. In my earlier video, I introduced you to supports and support reactions. I have also introduced you to the concept two-force member. Today we are going to start solving problems on equilibrium of coplanar system of forces. We are going to study Lami's theorem with some examples. We are going to solve problems in which all members will be two-force members. So let's begin. Read the problem. Example 1. A block of weight 25 Newton is suspended using a system of inelastic wires as shown in the figure. Find tension in wires BC and BD. Okay, so a block is supported using a system of wires. When you watch this diagram, immediately what you should understand, all members here in the system are two-force members. What do you mean by a two-force member? I have made a separate video on two-force members. You should refer that video. Nothing to think about wires. Any straight portion of a wire is a two-force member. So, when we say FBD of a joint B, what do you mean by free body diagram? What do you mean by FBD? So, FBD is a free body diagram. What is that? It is the diagram of a body under consideration in which we show all forces acting on the body. So when you say here FBD of joint B, it means it is diagram of joint B showing all forces acting on joint B. So most important thing is in this problem, what is there in the problem that suggested you to draw free body diagram of joint B? So remember this statement, note down as a point to remember. If all members meeting at a joint are two-force members, then draw FBD of the joint. So watch here, at joint B, the three members meeting here, BC, BD and BA. So let's draw FBD of joint B. Joint in the sense the point where members are in contact or members are connected. So it is joint B here, where three members are connected. So joint B is nothing but point B. So FBD of point B you are going to draw. Now one more thing, pay attention to this. When you say diagram of a body under consideration, this phrase body under consideration is a concept. A body under consideration need not be a body. It can be group of bodies together, or it can be a portion of the body, or it can be a single point in the body. So body under consideration can be anything. Okay, so right now we have drawn free body diagram of a joint. FBD of a point is a concurrent system and it can be solved for two unknowns only. And therefore, when you select a joint to draw free body diagram, be sure that there are not more than two unknowns and at least one known force. So why we have drawn FBD of joint B? So two things. Here is a joint where all members at the joint are two force members. And second thing, at joint B there is one known force. And what is that? It is a pull by wire AB, that is 25 Newton. And two unknown forces, that is pull by wire BC and pull by wire BD. Remember, wires always pull the bodies they are supporting. So wire BC is pulling point B, wire BD is pulling point B, and also wire AB is pulling point B. Wire AB is pulling point B downwards with this force 25 Newton. So we'll draw free body diagram. Now always follow a proper procedure to draw free body diagram. Procedure of drawing free body diagram. Very first thing is to draw diagram of the body, means the body under consideration. Then show weight of the body. And where this weight is to be shown? At the center of gravity of the body. Weight is always vertically downward force. It is gravitational force acting on the body. Then externally applied forces on the body. Show externally applied forces as they are given in the problem. As they are mentioned in the problem, as they are given in the diagram, you are going to show externally applied forces What I said, as they are given. So there is no possibility of mistakes in showing externally applied forces. And finally, forces by other bodies in contact with the body. So forces by other bodies which are in contact with the body under consideration. These are actually reactions. So to show these forces by other bodies, nothing but reactions. Watch the video, link of the video is given here. Okay, so according to this procedure, let's complete free body diagram. So what is first step? Diagram of the body under consideration. So in this case, we should draw diagram of point B or joint B. So how to draw diagram of a point? Draw horizontal line, vertical line. So this point of intersection is that joint B. Then in this order, show the forces. First, weight of the body. Now here the body is joint B. So weight of joint B. There is nothing like weight of a point or weight of a joint. So this step is over. Second step is over. Now third step. Externally applied forces on the body. So watch the diagram. There are no externally applied forces shown on point B, or nowhere it is mentioned that there are externally applied forces on the system. So third step is over. There are no externally applied forces. And finally, forces by other bodies in contact with the body. So there are three wires pulling point B. Wires always pull, and this pull is along the wire. Wire AB is vertical wire, pull is vertical. And this pull is known as 25 Newton. So this is force exerted by vertical wire, that is wire AB on point B. Force exerted by, and it is equal to weight of the block. And now one very important statement I am making. A two force member transfers force from one end to the other end. So 25 Newton force here at A, this force, this member transfers to point B. Wires are always in tension. Means wires always pull bodies they are supporting. And therefore we use this letter T. If a body is in tension, it pulls. And if body is in compression, it pushes. This is a pull, means a tension, and that is why we have used letter T. So develop habit of showing force by a wire, a flexible support. Wire, chain, belt, rope, you should use letter T. Now let's show force by wire BC. So along wire means 60 degrees with vertical. Since its magnitude is unknown, we should label it TBC. Similarly, force by BD takes 55 degrees with horizontal, and let's label it as TBD. So this is how we have completed the diagram. Forces by other bodies. There are three bodies meeting at point B, BC, BD and AB. So show forces by these three bodies. So FBD is complete. So these are the forces acting at point B. What is the type of system it is? Concurrent system. How many unknowns are there in the system? Two unknowns. Magnitude of this pull and magnitude of this pull. So even if we can solve this problem using the two conditions of equilibrium, sigma fx equal to 0 and sigma fy equal to 0, we'll prefer Lami's theorem. So even if it's not necessary that you must use Lami's theorem here, I'll recommend to use Lami's theorem for a concurrent system with only three forces in equilibrium. So what is Lami's theorem? Let's try to understand. Lami's theorem. If three concurrent forces are in equilibrium, then their magnitudes are directly proportional to the sine of opposite angle between the other two forces. So here are three concurrent forces. Can we apply Lami's theorem? Wait. Lami's theorem is not for three concurrent forces. Lami's theorem is for three concurrent forces in equilibrium. So now I am giving you information. These three forces are in equilibrium. Can we use Lami's theorem? Yes. And what it is? F1 upon sine theta 1. F1, its magnitude of force F1, divided by sine of opposite angle between other two forces. So angle between F2 and F3. That is equal to F2 upon sine theta 2. F2 divided by sine of opposite angle between other two forces. That is equal to f3 divided by sin theta 3. f3 divided by sin theta 3. So this is Lami's theorem in mathematical form, provided f1, f2 and f3 are in equilibrium. Now one very important thing I am going to tell you. Here, if these three concurrent forces are in equilibrium, then we can use Lami's theorem. f1 upon sin theta 1, f2 upon sin theta 2 and f3 upon sin theta 3. Have you noticed the change? f2, we have used a negative sign. So here, what is very important you should understand, if there is a push type of force is involved, you should use negative sign with its magnitude. Remember now, while using Lami's theorem, if push type of force is involved, use negative sign with its magnitude. Note down this as a point to remember. So Lami's theorem is only for three concurrent forces in equilibrium. If there are more than three forces in equilibrium, no worries. We use conditions of equilibrium, sigma fx equal to 0, sigma fy equal to 0. So let's come to our problem. Here is a system in equilibrium. We are using Lami's theorem. So by Lami's theorem, TBC, that is this force, divided by opposite angle between other two forces. So it is 90 plus 55, that is 145, is equal to 25. Don't use negative sign, we are not adding forces. I have seen many students getting confused because of downward direction of this force. While using Lami's theorem, we are not going to consider direction of the force, but we consider nature of the force. Next, TBD divided by sin 120. TBD divided by sin 120. It is 30 plus 90, that is sin 120. So when you use Lami's theorem, actually you get two equations. This is one equation and this is the other equation. Using these two equations, you will get TBC. First equation gives you TBC. Second equation gives you TBD. So these are the answers. Now one more very important thing. Find tension in wires BC and BD. If you are asked force in a two force member, here it is a two force member. If you are asked force in a two force member, then you should write answer in magnitude and nature form. That means in the answer, direction is not required but nature. But wires are always in tension, and that is why we have already used letter T. So it's not necessary to mention once again that it is a tension, because it is understood in this letter. So force in a member must be defined by its magnitude and nature. And nature, how you describe nature of a force? Using these words, tension and compression. Tension means pull type of force. If body is in tension, it pulls. If body is in compression, it pushes. So write answers properly. So these are the answers. So what you studied in this problem? We draw FBD of a joint only when all members meeting at the joint are two force member. We never draw FBD of a two force member. Doesn't mean that we can't draw FBD of a two force member. It simply means we don't get any new information by drawing FBD of a two force member. You will understand it better after solving one more problem. AB and BC are rigid weightless rods. So these are weightless rods. A, B and C are pin joints. A, B and C are pin joints. A 120 kilonewton force is applied at joint B as shown in figure. So this is that 120 Newton force applied at joint B. Find force in rods AB and BC. Draw FBD of joint B. Before you draw any free body diagram, you should know angle of inclined member AB. So let's first of all find out that angle. So this triangle is nothing but this frame. Just draw line diagram of the given system. Here no forces are to be shown. Just insert all known dimensions to get angle of line AB either with vertical or with horizontal. So in this triangle you will get angle of rod AB with vertical. Use sine rule and you will get that alpha. 5 divided by sine 45 equal to 2 divided by sine alpha. And this is how you have found out alpha. Now, AB is a two-force member, BC is a two-force member. How will you come to know that? Listen, earlier problem I told you that supporting wires are always two-force member. But what about rigid rods? So, if a rod is weightless, connected at ends only, no force acting in between ends, and no couple is acting on it, such a member is a two-force member. So here rod AB is a two-force member. It is connected at ends, no force in between ends, no couple on it. So such a member is a two-force member, and that is why we know that rod AB is a two-force member. Rod BC is also two-force member. And when all members meeting at a joint are two-force members, we should draw FBD of joint. So we are drawing FBD of joint B. FBD of a joint is a concurrent system which can be solved for two unknowns only. So there are only two unknowns at B. So let's draw free body diagram. An important point to remember, if all members meeting at a joint are two force members, then draw FBD of the joint. So FBD of joint B or FBD of point B. Diagram of the body under consideration, diagram of point B. So here it is point B. Then weight of the body. There is nothing like weight of a point. So this second step is over. Third step, externally applied force. Yes, there is one externally applied force. It is to be shown as it is. So it is shown at B 120 Newton downwards. So at point B 120 Newton downwards. These are two rigid two force members. How to show force by a two force member? Assume pull type of force. So force by rod BC. 45 degrees with vertical. Label it with letter F. If it is wire, we use letter T. And rod AB, it makes alpha 16.43 degrees with vertical. This is how we have shown force by member AB. Now use Lami's theorem. FBC divided by, watch here, here it is FBC divided by opposite angle between other two forces. So 180 plus 16, 196.43. equal to 120 divided by opposite angle between other two forces. So this angle is 90 minus 16.43, this angle 90 minus 45. So total angle between the two forces is 118.57. FAB divided by opposite angle 45, and you will get the answer. First equation gives you FBC, second equation gives you FAB. So FBC is minus 38.65 Newton. FAB is 96.62 Newton. Now you are asked to find force in, watch here, force in rods AB and BC. So you should write answer in magnitude and nature form. That means you should write whether it is tension or compression. So let's write it. BC, FBC, 38.65, but we got negative answer, it means it is compression. And FAB, positive answer means tension. Now what is logic behind that? Try to understand. But to solve, while solving problem, remember, always assume force by two force member, a pull type of force. And when you get negative answer, it means it is compression. When you get positive answer, it means it's tension. FBC is negative. What does that mean? Direction in the diagram is wrong. That means this direction is exactly opposite to what we have shown in the diagram. That means FBC or rod BC is pushing joint B, and if rod BC is pushing point B, it must be in compression. Rod in compression pushes, rod in tension pulls. So this is how we have mentioned the answer. Simple. What you studied today? If all members are two force members, then we draw FBD of joints. We never draw FBD of a two force members. Also you studied how to identify a two force member in a system of members. Also you realized that a two force member simply transfers force from its one end to the other end. So these are all very important points you get to know. If you think that this video is really valuable to you, then like the video, subscribe my channel, share this video with your friend. It's always better to share the knowledge. Why to keep it